Welcome to AutoCAD. In the name AutoCAD, the last three letters CAD can variously stand for computer-aided design or computer-aided drafting or computer-aided drawing. Regardless of what we call it, it is the program that we'll use to create very detailed and highly accurate rigging and crane drawings for inclusion in lift studies. The screen that you're looking at the moment is the out-of-the-box workspace that you'll get with AutoCAD Lite. However, it's not the one that I use. There's a lot of wasted space here with the ribbon and a lot of commands that we don't use. So I've created a customized workspace where I've removed the ribbon and I've taken it back to icons that give us just the tools we need to do the bulk of our work. Now, as part of the training package, I will provide you with all of the customization files and templates required to get your AutoCAD looking and working exactly the same as this one and the one that we'll be following through all of the videos. So this is a program that we'll use to create drawings such as these. They could be very simple things. First we'll do a rigging drawing. It could be lifting a small concrete lid. It could be for something a bit more complicated, such as lifting a crusher mainframe, and it could be for extremely detailed, very large, complex rigging arrangements. For this one, which was a switch room that was 37 metres long and about 100 tonne. Regardless of what we're doing or what rigging drawing we're creating, we need to identify every single item of rigging. We need to give it a capacity and a weight and the quantity of them, which will give us subtotals. All of that will add up to a total rigging weight. In this case it came up to 15.2 tonnes. We also put in all the details for the cranes. It'll be hook weights, hoist rope weights if it's applicable, and that will then give us a total lifted weight. Once we have that, we can move on to crane drawings, and again the drawings can be as simple as lifting a small piece of precast with a franner. Could be something quite a bit more complex, such as a dual lift at a ball mill. We identify where each crane sits, where the transport sits, where the load starts and where it finishes. We go into a lot of detail about crane configuration, about the load and the lift details. In this case we go through the dual lift requirements and required capacities. We check the reeving is sufficient and what the utilisations will be, and of course ground bearing pressures. We can also produce drawings, what we call an elevation view. As an example, this was an LTM 1750 lifting a large stack on Gorgon. So that is in a nutshell what we can do with AutoCAD. This is the end of this video. In the next one I'll start to talk about the various commands and how we make things happen in AutoCAD. Thank you.